Hello, everyone. Today's lesson, we are going to be continuing to look and work with functions. We are going to be determining if they are linear or nonlinear functions, what makes the two different, and what they look like when we graph them or if we view them in an equation. Linear and nonlinear functions. When you graph a linear function, it makes a line. Clearly, we can see the word line right within the word linear, and we've used the word linear many times throughout the school year. We know the word linear means line. When you graph a nonlinear function, it does not make a line. So what we have here are examples of a linear function, and a nonlinear function. As you can see here, here's our equation, y equals 2x minus 2. If I take some x values, -2, -1, 0, 1, and 2, and I sub them into that equation or that function rule, 2x minus 2, 2 times -2 is -4, minus 2 is -6, 2 times -1 is -2, minus 2 is -4, so on and so forth. So we take our x and our y values and we create ordered pairs. When I graph them, we can see that it created a straight line. So the equation or the function rule y equals 2x minus 2 graphs linear. But if I take the equation y equals x squared plus 1, use the same x values, -2, -1, 0, 1, and 2, sub into them just the same, -2 squared plus 1, -2 squared is 4, 4 plus 1 is 5, -1 squared is 1, 1 plus 1 is 2, so on and so forth. We take our x values, we take our y values, we write them together, create ordered pairs. But when I graph this one, you can see that it does not create a straight line. So here's an example of a linear function, and here's an example of a nonlinear function. So what we're going to get to next is really looking at these equations or these function rules and determining what is going to make something linear and what's going to make something nonlinear. Hopefully by now you can kind of see something different in this equation that we haven't worked with a lot this year. We had an exponent of 2 on our variable of x. So whenever you have an exponent on the variable that is something other than 1, remember this one has a 1. When there's nothing written there, it's a 1. It ends up nonlinear. Everything we've worked with this year has been linear. Let's see some more examples, okay? So here's just a table showing us what makes something linear, a linear function, what makes it nonlinear. On linear functions, your exponent on x or whatever the variable might be is going to be 1, or there really won't be anything written there. That's how we know it's a 1. So for example, y equals -7x plus 9. A horizontal line would be a linear function. For example, y equals -3. Vertical lines are not linear functions because they are not functions. When you have a x equals line, your input, your x value, is the same all the way through. It is not a function. So that's why vertical lines are not written here. For example, for nonlinear functions, your exponent on x or something other than 1, for example, 2, 3, or 4, etc., there could be a variable in the denominator. Somewhere in your function rule, there's a fraction, and in that fraction, the denominator is a variable. We don't know what the options could be because they will vary, so it ends up being nonlinear. It changes throughout. If there's a square root symbol or a cube root symbol in your equation, it will graph nonlinear. Or if your actual exponent is a variable, therefore it would graph nonlinear. So here's a few equations. Let's go take a look at all those. Take a glance at them quickly. Y equals -1/2 x plus 7. Y equals 3x squared plus 4x minus 3. Y equals 3 over x minus 6. Y equals 4. Y equals x, or y equals 1x. And y equals 3 to the x power. This first one is linear. My exponent on my variable is not written there, so we know it's a 1, therefore it's linear. The second one is nonlinear. Having an exponent of 2, something other than 1, creates a nonlinear function. It's not going to graph a straight line. Oop, we're not in order in here, but we'll go with the flow. Y equals X. This is linear. Exponent on X is like having a positive 1. Even the coefficient of X is 1. Everything points to it being linear. Ooh, totally out of order, but that's okay. Number 4, Y equals 4. This is going to be one of those horizontal lines. It's linear. Y equals 3 over X minus 6 will be nonlinear. We have that variable in the denominator. That variable will change constantly. Therefore, it's not a constant, so therefore it graphs nonlinear. And finally, y equals 3 to the x power is also nonlinear because our exponent is a variable. It's forever changing. It's going to be something other than 1. Now let's take a look at some graphs. On the left side, here's some examples of linear graphs. On the right side, nonlinear. Clearly, this one right here is actually the graph of y equals x. Your y value and your x value are the same all the way through. We have 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. This is the graph y equals x. It's a linear function. Here is the function rule or the graph of the equation y equals negative 2. We can see that it is a horizontal line. It's a linear function. And this one down here is also linear. Now, 2 examples of nonlinear functions. And there are many more. These are just a few examples. Clearly, this one is called what's called a parabola, and it is nonlinear. It's not a straight line. But this one right here is not linear. Here's another example of a nonlinear function where we have an absolute value symbol. So y equals the absolute value of x. And the reason why this one is nonlinear, even though it kind of is composed of 2 straight lines, it's not a continuous straight line, so it's nonlinear. On this right-hand side from the origin up, the slope is 1. On the left-hand side, it's negative 1. 2 different slopes makes it a nonlinear function. Okay, so in your assignment you're going to have to determine whether or not certain equations are linear or nonlinear, and if they are, and same thing with graphs, if they're linear or nonlinear. Feel free to email me, message me via Google Hangouts or any of the above, and I can set up a Google Meet if you need to. Good luck.